This video is part 3 of 10.1, and we're going to go ahead and do 5 review problems to kind of recap and make sure we see the difference between what we've learned and our new math symbol, which is a function composition symbol. Okay, so if we take a look here, numbers 15 and number 16, that would be considered review. So that is not a function composition. So if we take a look at number 17, this is what we just learned in part 2. So this symbol here means that I'm going to take function f's output and plug it in for function g's input. Okay? Whereas number 15 has a plus symbol. So number 15 is saying to take function f, so function f is 6x plus 1, okay? And then it's saying to take that function and add it to function g. So function g is just x squared. So it's saying to just add these two. So in other words, I don't need these parentheses here because there's nothing in front to distribute or multiply. This is just a plus sign. So we're just going to combine any like terms, which there are no like terms, so we're just going to write it in standard form. This one has the highest exponent, so x squared goes first, then the 6x, and then the 1. Okay, so x squared plus 6x plus 1. And then in the parentheses here, it just has x. If there was a number here, we would plug in that number for x. So there is no number, so this would be our answer that it's looking for. Okay, so let's take a look at number 16. So number 16 is saying take function f, which is 6x plus 1, and it's saying to multiply by function g. So we could put two parentheses next to each other. That represents multiplication. Okay, so here we're multiplying. So that's how I know to distribute here. So I would have 6x times x squared, which that would make 6x cubed, because we learned to add the exponents when we're multiplying. And then we have 1 times x squared. And 1 times x squared is just a positive x squared. Okay, so we've done the multiplication, we distributed, and now it's an addition problem. So we can only add these if these are like terms. So they are not like terms, so then that would just be our answer, 6x cubed plus x squared. And in the parenthesis right here, it's just an x. That's why we're not replacing the x with a number. All right, number 17. Now this is what is new for chapter 10, is this symbol right here. So what I'm going to do is I'm going to go ahead and take function g, which function g is x squared. Okay, so I took function g right here. Okay, and I'm going to take out the x and plug in the whole, I'm plugging f of x in for g. So I'm going to plug in function f, so 6x plus 1, I'm going to plug in right here. I'm going to plug in 6x plus 1 in for x. Okay, and then if it's possible, you're going to simplify. So in this case, it is possible. Remember, we learned in previous chapters, you cannot distribute this exponent because of this plus right here. If this plus was not there, then yes, you would distribute. So we're going to do 6x plus 1 times 6x plus 1. We cannot distribute that exponent, so we're going to go ahead and FOIL and multiply here. Okay, so we're going to go ahead and do 6x times 6x. So that's 36x squared, because we add the exponents when we multiply. And then we have 6x times 1. That's positive 6x. And then we have 1 times 6x. It's another 6x. And then we have 1 times 1, which is positive 1. Okay, so we did the exponent part. Now we're going to go ahead and combine the like terms. And then that would be our answer. There is no number in here, so that's why we didn't do anything with that. So we just get 36x squared plus 12x plus 1. So again, when we see that symbol, we're taking function f's output and plugging it in for function g's input for the x spot. Okay. Now if we look at number 18, this has a minus. So it's saying take function g, so function g is x squared, and then subtract function f, so 6x plus 1. So that's what this is saying. Okay, so we're going to go ahead and subtract, so I can distribute this or the negative here. So remember, a minus in front of a parenthesis just switches the sign, so the plus 1, the 6x is now negative 6x, and the plus 1 is now negative 1. Okay, now there's a 3 in here. So now we're going to go ahead and plug in a 3. Instead of leaving the x's there, we're going to go ahead and plug in 3. So we're going to take the x's out and plug in 3. So 3 squared is 9. Negative 6 times 3 is negative 18. And we get negative 10. Okay, so I went from left to right. I did the g minus f and then plugged in the 3. The other way to do it is if I go from right to left. So if we're going to go from right to left, we're going to start with plugging 3 in for function f. So plug in 3 for function f. And we get 19. Okay, now we're not going to plug 19 in for function g, because that's what we would do if it was a function composition. This is just saying plug in 3 and subtract the 2. So I'm going to, again, now I'm going to plug in the 3 for the g. So I'm using the same number because this is not a function composition. So now I'm going to plug in 3 for function g. Okay, so we get 9. Okay, so I'm plugging in the 3 for each of these and then subtracting. And 9 minus 19 is negative 10. So again, look at the difference. When you're doing a function composition like this one, number 13 from part 2 video, if there's a number there, if you're going from right to left, you plug that number in, and then the answer you get goes in to function f. That is not what's going on here. Here you're plugging a 3 into both of them, and it says to subtract. So you would only plug the 19 in for g if this was a little circle, an open circle. Okay, now we're going to go ahead and review part 1's video, which is to find the domain. So this is saying to take function g which is x squared, and divide by function f. Okay, so we're going to go ahead, it says find the domain of this whole thing here. So this, it doesn't ask you to simplify this, and it can't anyways because of that plus there. All it says is just to find the domain. So when we find the domain, domain just means what can you plug in for x. Well, you can plug in any number for x here. The numerator of a fraction can be any number. But the problem is the denominator can never be 0 of a fraction. So we need to solve for what number is bad, and we'll make the denominator 0. So I'm going to go ahead and subtract 1, and then divide by 6. And this is the only number that x cannot be. So if I draw that in a picture, it can't be. That's why I'm putting the open circle, which means I need to put a parenthesis here. It could be any number, just not that one. So my domain would be any negative number up to negative 1/6, not including it, and anything greater than negative 1/6. So any of these numbers can go in either X spot, and we'll make this a real number, just not negative 1/6.